Mathematical practice number 2. Reason abstractly and quantitatively. The standards for mathematical practice, often called the mathematical practices or the math practices, can be found on pages 48 through 50 of the College and Career Readiness Standards for Adult Education. These practices describe behaviors and thought processes that support mathematical thinking and reasoning. So that students have experience with all 8 practices, it's the role of teachers to encourage the practices and incorporate them into activities. In this webcast, we'll focus on mathematical practice number 2, reason abstractly and quantitatively. So, to begin to get a sense of mathematical practice number 2, reason abstractly and quantitatively, let's consider a scenario outside the math classroom. Think about the ways that we could work with the numbers in a checking account. While shopping one day, I see that the laptop that I have been wanting is on sale for $699. Do I have enough money in my account to buy this? By checking the balance, I see that I do have enough money. The balance is a summary of the withdrawals and deposits for that account, and I checked to make sure that no transactions were pending, so just looking at that number gives me the information that I need. The contexts of the previous withdrawals and deposits don't matter in this case. Sometimes, though, those contexts do matter. If I want to find out how much money I spent on utilities in the past 6 months, I would have to filter the withdrawals for the utility companies and then find a total of those amounts. If I want to confirm that I paid my license plate renewal this year, then I'll have to search the withdrawals and find that particular fee. When we reason abstractly and quantitatively, we are able to contextualize and decontextualize quantities as needed in order to solve the problem at hand. Now that you've got a sense of the meaning of this practice, let's look more deeply into what it means to reason abstractly and quantitatively. I'll highlight 3 features of this mathematical practice, as well as example activities at different levels that work with each feature. All of the math content examples that I share can be found in the College and Career Readiness Standards for Adult Education. When you work with mathematical practice 2, you'll be guiding your students to make sense of quantities and their relationships, decontextualize by representing a situation with symbols, or contextualize by connecting symbols to their meaning in a given context. First, let's look at feature 1, make sense of quantities and their relationships. To encourage learners to make sense of quantities and their relationships, you could ask them, which numbers are needed to solve this problem? What is the meaning of each of those values in this situation? How could you organize them in a helpful way? For example, at a lower level, you could give students cards listing various quantities. You could then ask them to sort the cards according to categories that you provide. You could even ask them to order the cards from least to greatest. Ask students to explain their reasoning to each other as they make decisions about the quantities and their relationships. Look at this garden sketch. How many feet of a 6-foot tall fence will you need to enclose this garden? At a higher level, students can make sense of quantities and their relationships by working with problems containing extra numbers that are not needed to solve the problem and with various units that may need to be converted before doing the computation. By encouraging learners to make sense of quantities and their relationships, you'll see them look carefully at given quantities as they determine their usefulness in solving the problem at hand. Before we continue to discuss the second and third features of Mathematical Practice 2, Reason Abstractly and Quantitatively, let's look at the meanings of two key terms used in the description of this practice: contextualize and decontextualize. When we ask learners to decontextualize, we are asking them to think of the given problem in an abstract way. For example, learners will decontextualize when they represent 21 lunches and the cost of the meeting room as 21x plus r, with x representing the cost of each lunch and r representing the cost of the meeting room. When asked to contextualize, we are asking learners to see the quantities within the context and implied constraints of the given situation. You'll see with the following examples that mathematical thinkers are able to decontextualize and contextualize as needed during the problem-solving process. Now let's continue to the second feature. To encourage learners to decontextualize by representing a situation with symbols, you could ask them, can you write an expression or equation that represents this problem? Which variable will you use? What will that variable represent? At a lower level, students could match a phrase with its corresponding numerical expression. For example, the phrases that you see on the left of the screen each match with an expression on the right of the screen. The cost of 6 sweaters and 7 shirts, each costing $20, matches 20 times the quantity, 6 plus 7. The area of 20 tile floors, each with a width of 6 feet and a length of 7 feet, matches 20 times the product of 6 and 7. The value of the inventory after 6 of the 7 $20 frames were sold matches 20 times the difference of 7 and 6. After completing a similar exercise, you could ask students to write their own numerical expression for a given phrase. Students may write different expressions that accurately describe the given phrase. If that happens, ask them to share their reasoning, then do the computation to see if the result is the same. Depending on the level of the group and the phrases that you choose, this may be a good time to introduce the associative, commutative, or distributive property. At a higher level, you could ask your students to match a linear equation to a given scenario. The cost of a plumber that charges $100 for a home visit plus $75 per hour matches y equals 75x plus 100, with x representing the number of hours. The number of peppers, if you harvest 100 from each bed and 75 from the greenhouse, matches y equals 100x plus 75, with x representing the number of garden beds. Your account balance, given that you deposit each $75 paycheck and gave $100 to your niece, matches 75x minus 100, with x representing the number of paychecks that you have deposited. After completing a similar exercise, you could ask students to write their own equation for a given phrase. By encouraging learners to decontextualize by representing a situation with symbols, you'll find that you will see them more automatically represent problems using symbols like numbers and variables. The third feature of Mathematical Practice 2, Reason Abstractly and Quantitatively, is to contextualize by connecting symbols to their meaning in a given context. To encourage this, you could ask learners, does that make sense in the context of the problem? For example, the matching exercises that we just completed could be done in reverse. The expressions or equations could be given and students could be asked to match them to the correct scenario. Also, at any level, students could determine which solutions were reasonable or unreasonable based on the context of the problem. For example, they may think 48 inches is too small for the length of a field. Or, if x and y are positive integers, y can't equal -4. Or, it makes sense that the circumference is about 3 times the diameter. By encouraging learners to contextualize by connecting symbols to their meaning in a given context, you'll see them checking to see if their answers are reasonable based on the information they were given. Each of the previous examples illustrates how students could reason abstractly and quantitatively. Now let's watch these 8th graders as they reason abstractly and quantitatively.
My name is Susie Moorhead. I teach at Turkeyfoot Middle School in Edgewood, Kentucky, and I teach 8th grade pre-algebra and algebra. This lesson was a wrap-up of linear equations, some of the systems of equations, but kind of more the meaning behind it. What do these things mean? Not the manipulation of the math, but what things really mean. All right, clear your boards. Let's go to a story. The following ordered pairs represent the number of hours worked and the pay received. So calculate the slope of the line that connects these points, and then I need you to write down what the slope represents for the story. I need your explanation. What does the slope represent in this case? What does that number mean? My students have practiced the different formats that a linear equation might appear, and what the different parts represent, what the intersection point might mean, why we even find it, different ways of solving it. Okay guys, I got some boards here that I want you to take a look at. Some of these have different numbers on them. This one says 22.95 divided by 3. That says 22.95 divided by 3. And then it says this 7.65 business. And then, may I borrow yours? Because I just saw some new numbers here. 15.3 divided by 2. How does that happen that we have different numbers? Macy, what do you think?
They may have just chose 2 different points to find the slope between.
Does it matter which ones I pick?
No.
AJ, why doesn't it matter?
Because they're linear. They're all going in a straight line.
The slope is the same no matter which 2 points you pick.
How did the students in the video demonstrate that they were reasoning abstractly and quantitatively? Did you see them making sense of quantities and their relationships? Did you see them decontextualizing by representing a situation with symbols? Did you see them contextualizing by connecting symbols to their meaning in a given context? All 3 features may or may not have been demonstrated in this particular video. What other mathematical practices did you observe? Feel free to pause the webcast while you think about or discuss these questions. The students in the video were asked to find the slope of the function and explain its meaning, given 3 data points. Students do not need to be at a high level to graph points on a grid. You could introduce this skill by using small positive numbers in a familiar context. Just be sure to work with relationships that change at a constant rate. For example, you could work with a context of every person paying $5 for an event. The x-axis would count the number of people, and the y-axis would measure the total amount of money. In conclusion, I want to share this poster that summarizes Mathematical Practice 2. The next slide shows the link where you can download this poster to print and post in your class, as well as links to all of the other resources used in this webcast. How will you encourage students to reason abstractly and quantitatively?